to the 3rd through 5th grade Science Expo. This is our first year and we're really excited. We have a group of teachers here helping for registration. Say hello, everybody. We have some here. Look at you getting out of the way here. But we're really excited to see our kids, our students coming out and see all the different types of science experiments for the expo. So this is exciting. So thank you guys.
And I'm doing making electricity with magnets. So I have wires on the bottom that connect to lights, and here's the batteries. And when you turn the switch, it makes this go and the lights turn on.
I was looking around, my dad was looking around with me on Facebook and we saw it and then we wanted to do it because it looked so fun.
Shoot it at the camera. Like, shoot it at me.
And I made a computer, something kind of like a computer. Now back here, there is a battery powering this light. And this wire, if I stick it to a math problem, 4 times 4, and I get it right, like 16, this light will light up. And for example, here is 4 times 4, and here is 16. The light lights up. Now, if you get it wrong, then the light does not light up.
I made a Lego Catapult, and this. It shows my data is right there in the charts, and then I have where I got it from, where I got my data from, and then there's my design materials and construction, and then my past experiences, my conclusion and results, and then I have my title, battery-powered Lego Catapult, and problem statement. My goal is to build a catapult that will hold a marble until ready to launch.
My project is a generator. And how it works is you turn this handle, turns this rubber band, and it makes this motor spin, and the motor spins, it converts the energy from this rubber band into electricity that goes through these wires and make the lights light up.
I've done a catapult that is supposed to just launch the object. I got inspiration from my sister doing robotics almost every year. So I thought I would do a robotics for this science fair.
My project is called the Unbreakable Egg Pillow. It took me 6 tries, and it tells whether how an egg, like if you drop an egg, it won't break and you don't have to clean up a big mess. 6 pieces of toilet paper, 2 small pieces of aluminum foil, 6 inches of string, 4 cotton balls, and 1 rubber glove for this project.
This first one is the Apatosaurus. His name is Deceptive Lizard. And he used to be called Brontosaurus, but he's not named that anymore. He lived during the Jurassic period, and he is a diplodocoid dinosaur because he's got a very long tail. And next is a small sauropod called Europasaurus. The Europasaurus' name is reptile from Europe because that's where he got his name, and that's where his fossils were found. And he looks like Brachiosaurus but smaller because he's in the same dino family along with the Brachiosaurus. Supersaurus doesn't reach real up high, but it can go down to get some food from the ground and some water. The Volcanodon is about the same size as the Europasaurus, but just like the Europasaurus is smaller than Brachiosaurus, he's a little bit smaller compared to the Europasaurus. And lastly, the Amargasaurus. The Amargasaurus' name is La Amarga Lizard because sometimes he had spikes on his back or his tail. He lived in the Cretaceous period, and he's also a small sauropod, but he's slightly larger than a human. And Amargasaurus was discovered in 1976. I don't know. And that's it.
My project is elephant's toothpaste. So what you do, you add 2 tablespoons of warm water, 1 teaspoon of dry yeast, 1 cup of peroxide, and you add a squirt of soap, and then you add streaks of food dye. The chemical reaction of this is that elephant toothpaste is a decomposition process of hydrogen peroxide, while yeast potassium iodide, it works as a catalyst to break down the hydrogen peroxide into oxygen, while water, which turns into foam. And the person who made elephant toothpaste was Science Bob. There is a world record of it, and this could be used to use elephants' teeth to clean them.
My invention is called the Puff Muffler, and it makes your fart smell less stinkier. What it is about is how you have a couple of things that you can use from your house instead of store-bought. All you have to do is grab thread, a needle, some odor neutralizer sheets, and then a pair of underwear. All we did is we sewed a pocket in the back of the underwear, and then we made a spot for the odor neutralizer sheet, and then we just sewed the word Puff Muffler on the back of the panties. You will know when to take out the odor neutralizer sheet because it will turn yellow.
And I made something for whenever you're tired, you have this whole big weekend plan, you don't want to get up in the morning to get some food. Well, I made a tray, basically just a tray with wheels that goes down a railroad track so you can pull a string and then you got breakfast right next to your bed. So, this is the skateboard's representing the tray's wheels, and then this is the tray, and then obviously the string. And then this is your bed, that's your kitchen, this is just a random dining room. You got some food on there, you're hungry in the morning, you got your string, so you just pull it towards you. Bam! Food!
When you rub a magnet on one side of a needle, then the needle will it'll get magnetized and it'll face north.
Can you demonstrate?
Right here. It's facing north right now. Right there. Now it's facing north, so if you do this, it'll go that way, then it'll always go back north.
And I did a electromagnet, and I thought my hypothesis was 10 reps would be 20 and 25 would be 25 and 50 reps would be 30, which it was. And well, the 10 was 1 clip, the 25 was 4, and the 50 was 30.
Cool. You're so smart.
It picks up 2.
This is my science fair project. It's about chickens and hatching them. This was first phase, wherever we got them out of the box. Then we're putting the humidity in. Water for the humidity has to be at least 60%. We got the egg. We had to put in the egg turner, so they will if the yolk, it has to move the yolk. If it gets stuck to the side, it possibly make the it will make the chicken deformed or just not born at all. Now, since we're on that topic, let me explain to you what the red ring of death is. If you're candling the egg, when you're candling the egg, you want to look for movement and vein development. If you see this red ring of veins, then that means the chicken has died, because whenever the veins settle inside the yolk, it'll turn into a ring. That's on the. It's on the tip of my tongue. It's on Okay. The temperature has to be at 99.5 degrees Fahrenheit. Then we also the beta phase of this, when we weren't planning on making this yet. We also have this is showing the stages. We have that state day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8, day 9, day 10, day 11, day 12, day 13, day 14, day 15, day 16, day 17, day 19, day 20, day 21. I'd say around 21.
And my experiment was on putting food coloring in flowers water, and I did research to find out that what should happen is that due to the color of their water, their petals should change that color. And I thought that that would happen within 24 hours. What we did was I took my food coloring and put it in the flowers water, and then I left them for a day, which would be 24 hours, and none of them had changed at all except for the orange, which had just a little bit of orange in their petals. And then the second day it was the same, except the flowers were wilting and it was faded orange in the orange. And my variables were, I could have used liquid food coloring, but I used gel food coloring. And I used daisies and carnations, but I could have used roses. And I used room temperature water, or I could have used warm or cold water. And I rejected my hypothesis because it didn't work, but only in the orange flowers.
For my experiment, I did rainbow milk. In this experiment, I will use chemistry to show how 3 milk substances, 2% milk, creamer, and heavy cream react to this soap. What happens when you mix milk substances with dish soap? Does the reaction change between the 3 substances? Which milk substance will react the longest and which the shortest? I predicted that the creamer would react the longest and the 2% milk would react the shortest. But my prediction was the opposite. The creamer reacted the shortest and the 2% milk reacted the longest. Then I put 2 drops of food coloring in each of the plates.
We did muscle irritability. This is an experiment testing the effects of cold temperatures on skeletal muscles. Our testable question was, how do cold temperatures affect your muscles?
And what we thought, our hypothesis was cold will make your muscles tighter and shorter, which means they would get slower. And so our scientific process was the materials you need are a clothespin and a bowl of ice water. The first step is to get the clothespin and count how many times you can pinch it on your dominant hand in 1 minute. Then you record your data.
Put your dominant hand in the bowl of ice water for 1 minute. Take your hand out of the bowl for another minute and count how many times you can pinch the clothespin with your dominant hand. Record your data. Repeat the whole process on your dominant hand 2 more times.
Background information. Muscles are things that get longer and shorter, and muscles are made of fibers. The muscles that we tested are the skeletal muscles. Skeletal muscles move bones, and most are voluntary muscles. Voluntary muscles are muscles that your brain tells to move. Involuntary muscles are muscles like your heart that move automatically without you telling them to. There are 640 muscles in the human body. The importance of this project is to explain how your muscles get tighter and shorter when they are cold. If athletes didn't know that, they would be slow because they wouldn't know to do their stretches to warm up their muscles. A Swiss biologist named Victor Albert von Haller was the first scientist to discover the relationships between muscles and nerves. Von Haller performed 167 experiments that showed that irritability is an important property of muscle. Muscle irritability means that muscles become shorter and thicker. Cold temperatures can cause muscles to be irritable.
We have ice water right here. We did ours for a minute, but we're just letting people stick their hand in.
Yeah.
Just see if they can do it.
My question was, does vinegar clean a dirty counter as well as Windex and bleach? My hypothesis was that bleach will clean better than vinegar, and vinegar will clean better than Windex. I did some research and I found out that vinegar kills some but not all bacteria. It is not registered as a disinfectant by the EPA. Windex kills some but not all bacteria and is not registered as a disinfectant by the EPA. Windex is bad because it can cause coughing and throat and nose irritation, and it can cause poisoning. Counter control is the one that's just of the counter without any spray. And then counter Windex is it with Windex, is the counter with Windex. Counter vinegar is it with vinegar, and counter Clorox is it with Clorox. It cleaned all the way. The only thing is that it's really bad for us.
We got big rocks, gravel, sand, and cotton balls, and those layers clean the dirty water. Cotton balls, gravel, sand, and rocks.
Okay. Oh, there it comes.
So I was talking about continuity and conductivity of a circuit in a citrus battery. So here we have a switch, which should have a gold part in it and a metal part. When you put them together, you're creating an open circuit. So I also have an experiment I'm going to do. Well, it should be moving, but no. I have an experiment. I do Boy Scouts, and at the end of the year, we do something called the Pine Wood Derby, where we build cars made out of wood and we race them down tracks. I changed this idea up a little bit, and I wanted to see which car would be the fastest and would the weight matter. My hypothesis was the heaviest would equal the fastest. In the end, my hypothesis was incorrect, but I think the lightest was the fastest, this one. I think there is a limit, like 6 grams or something like that, and that is like 6 grams a down, like a feather. I thought of a feather. It pushes the air up. It pushes the feather up the air. I thought that the lightest car would do that in my hypothesis. I think that the grams on this car, the lightest one, was like the sweet spot of it, that was the limit of if it was this heavy, heavy, it would go faster. They don't have, animals or projects don't have names, they have numbers. So I wanted to do that with my cars, but they would also have the names so I could number them all and get them organized more.
I was doing Whopper versus Impossible Whopper, and my question is, does the Impossible Whopper taste like 100% beef Whopper? And my results are, my hypothesis was incorrect. The Impossible Whopper did not taste like plants. No, but rather a regular burger. I also found that the burger had a grilled taste. Burger King regular Whopper, Burger King Impossible Whopper in test subjects. And I asked 7 people to taste them, and they all said those are the same. My procedure was, first I asked to be driven to the nearest Burger King. We proceeded to order each burger plain in order to get the results without having any condiments to take away from the experiment. Once my order was ready, I took a bite of the Whopper, and then I took a bite of the Impossible Whopper. I repeated this procedure twice. I then asked our other test subjects to taste each burger. And my hypothesis is, I think an Impossible Whopper will taste like plants. In this experiment, we will put Burger King to the test. And this is all for the Whopper versus the Impossible Whopper.
And my project is about bacteria on teeth in dogs versus humans. The question for my project is, which will grow more bacteria, dog or human teeth? The hypothesis was, I thought the dog teeth would grow more bacteria. The process for this project, the Petri dishes were labeled 1 control, 2 human number 1, 3 human 2, 4 human 3, 5 dog 1, 6 dog 2, and 7 dog 3. We got a sterile cotton swab wet. We opened the Petri dish's number 1's lid. We swabbed the Petri dish 1 with the wet cotton swab, then closed the lid on 1 and placed it in the incubator. We swabbed the teeth of human 1 after again getting the sterile cotton swab wet. Repeated the process used for Petri dish number 1 for swabbing the Petri dish and replacing the lid and placing it in the incubator. Variables are what I changed, the dog teeth swabs and the human teeth swabs. What I kept the same was the temperature, incubator, and the process. What I measured was how much bacteria grew in the Petri dishes. Dogs definitely grew more bacteria.
And my project is about an egg getting sucked into a bottle by a match. My question is, how does it happen? Well, whenever I put the burning match inside the bottle and I put the egg on top of the mouth, since the egg blots out most of the air from the match, it makes the molecules go farther away from each other. And that makes a vacuum to the egg, so that's why the egg gets sucked into the bottle. The egg is getting sucked into the bottle.
My project, I did the best readily available hot beverage insulator. Some of the things you would need for this project was Chinette hot beverage cups purchased from Walmart or a grocery store, several readily available home insulating materials, an infrared thermometer which can be purchased at a hardware store, black electrical tape, a kitchen pot and stove to heat water, a digital micrometer, and water. The reason we would need this black electrical tape is because it had an emissivity of 0.95. Emissivity is the ability a surface has to radiate temperature. What we did first to start this project was we heated water to a boil on the stove. And then what we did was we poured it in to some of the cups, but we only could do a little at a time since we only had 20 minutes for each group. We took data for each 20 minutes and put it on spreadsheets. The thing we did for a picture was a lineup of our insulating cups. So as you can see, we taped the insulator to the cup. We took thermometer readings on the bare cup, the taped cup, the bare insulator, and the taped insulator.
We're trying to figure out which toothpaste would clean the teeth better. So we did Aquafresh, Crest 3D White, and Colgate, and then we scrubbed them 3 times for 3 trials. And the stains were coffee, tea, and Coke. And then so Aquafresh was like the winning one, and then Crest 3D White was the loser, surprisingly. And my hypothesis was incorrect because I thought that Crest 3D White would do it better, and then I thought that Coke would stain it the worst, but coffee ended up staining it the worst, so yeah. 3 being the lowest, 1 being the highest, so Aquafresh won, then Crest 3D White, then Colgate. Then Aquafresh, Colgate, Aquafresh, Colgate, then Crest 3D White. So they were very different each time. And then, so Aquafresh won. Aquafresh finished first 4 times. Crest 3D White finished first 2 times. And Colgate finished first 3 times.
My project is about making a butterfly made out of tissue paper fly with the power of a magnet. And I think that when I move the magnet close to the butterfly, due to the magnetic pole between the magnet and the paper clip, the butterfly will follow the magnet into the air. The thing I did was I taped a paper clip and one end of a piece of string to the back of a butterfly. Then I taped the other end of the string to the shoebox. Then I moved the magnet closer to the butterfly until I can see the butterfly go towards the magnet. Then I moved the magnet into the air to make the butterfly fly. And I can control it like that.
Today, my science fair project was making plastic out of milk. The supplies you need are 1 cup of milk, 4 teaspoons of vinegar, 2 mixing bowls, 1 spoon for stirring, 1 strainer, paper towels, cookie cutters, and food coloring is optional. The first thing you'll do is heat 1 cup of milk for a minute. Then you'll add vinegar to your heated milk. When you stir, clumps will begin to form.
Then you can drain your excess liquid using a strainer. You can then pat dry with paper towels to remove all excess liquid. Next, you'll flatten your casing, which is what the product is called. Choose a shape for your plastic or make one of your own and let it sit and dry for 48 hours. I made a car powered by a fan, and the axle spins inside of this straw, and then the positive wire from the battery connects to this switch, and then another positive wire connects to the motor, and then that negative wire does the same thing. And this is how it goes.
Project is density with colors. So I kind of made a rainbow in a jar, and so this is the main part on how you do it. So our problem is, how do the colors layer on top of each other? If you look down here, here's the mass in each cup. This is 8, this is 6, this is 4, and this is 2. And that's basically the tablespoons, how much tablespoons of sugar you put in each cup. And it actually allows the colors to layer on top of each other, forming a rainbow.
And I did a rubber egg, but before you can do anything and before you can drop it, you have to let the egg soak in the vinegar for 2 days, because you need a jar, egg, and vinegar. But in order for the experiment to work, you have to let the vinegar be higher than the egg, so that the egg can be fully under the vinegar, so the vinegar can dissolve the outer shell, because vinegar is actually an acid that dissolves outer shell, and under the outer shell is the membrane, and the membrane actually bounces instead of the main egg. And before you drop it, you can only drop it from like not that high, because if you drop it from a high place, then it will actually break, like I did at my school. This is the egg right here, but I can drop it and it will bounce, but if I drop it from like up here, it would like break. Like, it will bounce. And it's because of the membrane that's actually causing to make the membrane bounce. That's what it does.
All right, so this is Peyton, and Peyton has got a leak-proof bag. And why does it do this? What? So you poked a sharpened pencil through a Ziploc bag, and the water doesn't come out? Is that right? How did that? This is because the bag is made of a polymer, which is a long, flexible chain of molecules, and when you poke it with a pencil, they spread out apart, and then they seal themselves around the pencil.
Well, I did a chirality demonstration. So I have two polarizers. I'm just going to take this like this. Like that. It's like that. And so whenever this is facing up, this one, and this is facing up, it lights light through, because it's looking for light that's polarized upwards. Whenever I shift it, this one, top one, is looking for light that shifts polarized this way. But it's different here, so it'll block out all light. So my corn syrup, it shifts polarized light. So this light right here is polarized. So when I get this decides what light, what color will come through. And so you could see almost the entire rainbow. Yeah, you can see almost the entire rainbow. So the different wavelengths, you can see the different colors at different angles. So like I was saying, whenever I shift this,
you can see the different colors because it's at different angles.
I'm going to be studying bubbles. Bubbles are beautiful, but they are also very fragile. That's why I studied what object will hold a bubble for the longest time. The bowl of water would hold the bubble for the longest time because it has liquid, and that makes the bubble take longer to evaporate. And then I also found out which bubble solution was better, homemade or store-bought. I think that it was store-bought because the store-bought bubbles lasted the longest time, and it was the kind of bubble that lasted on the water for 110 seconds. Then, whenever I tested the cardboard, the palm of my hand, and the towel, the bubble popped immediately because it's something that absorbs water, which that made the water molecules be absorbed, which caused the bubble to pop. You can see these are my two types of bubbles. The homemade bubbles solution was made with 1 cup of water, a tablespoon of dish soap, and 3 squirts of foaming hand soap. And then but the aluminum foil and the bubble wrap didn't work as well for holding the bubble though, because the bubble wrap only had 2 times that it actually worked, and then the aluminum foil only had 1 time, except for the aluminum foil still had one of the higher scores because the bubble wrap made it to 7.24 seconds. And then the other one made it to 8 seconds, 0.64 milliseconds.
Hey, you got it.
My project is the balloon-powered bike, as you can see right here. The purpose of the balloon-powered bike is so that anyone can ride the bike. Like, some people can't ride regular bikes for medical reasons, and I just wanted to do something, and you wouldn't have to spend $1 million on batteries, and it would help our environment because we wouldn't have to pollute the air. I can't demonstrate right now because it won't work yet, but I'm working toward it. Because in Philly school, our word is yet. We can't do it yet, but we'll soon do it.
And this invention is called Laundry Ease because it makes your laundry easier. And it makes it easier because you get to turn on these switches. And you have to turn on all 3 of them. And this hole is going to come out with bleach because it says bleach right here. And this hole is going to come out with softener. And this one right here is going to come out with soap. You can tell because it says soap right here and softener and bleach. And this helps you so much because you don't have to hold up heavy containers, and you can only just switch that switch on the machine.
I did the Kernel Shifter. So the purpose of my invention is to be able to separate the unpopped kernels from the popped kernels. So the materials I used were a drill, a medium bucket, a large bucket, and a bag of popcorn. So first, you drill holes into the medium bucket. You drill holes into the large bucket, and then you place the large bucket into the medium bucket. Yes. And then you pour the popcorn into the bucket, and then you shake it. And then the popcorn will fall into this bucket, and then you can just throw away these.
Yeah.
This?
Yeah. So we can look down inside. Hey, it works.
I made a pencil pouch DIY, and I'm going to tell you all the steps of making it. So first, I cut out a pair of clothes, and it can be any size. that you want it. Then I have a picture of my workspace over here. Glue all holes together but leave one open. Then get a Ziploc bag and cut off the zipping part. Lastly, glue the zipping part to your one hole you have. There's your pouch.
I built a working catapult.
There you go. Yes.
Because I built a working catapult because I really like history, and I thought that one day if I could build a catapult big enough, I could use it for to sling basketballs into the goal. It took 2 days to build the whole thing. It can throw light, heavy, and small objects, but the heavy objects won't go as far as the small and light objects. The object that went the farthest was the ping pong ball, then the squishy, and then probably the cotton ball, because the cotton ball is too light for it to go as far as the ping pong ball and the squishy. The orange didn't go as far because it was the heaviest out of all of the objects.
My project is about how I did 2 natural foods and 2 processed foods, and how I checked myself for 30 minutes for 2 hours. My blood sugar had to be 80 to 150 for me to eat these foods. If it wasn't that number, then I couldn't eat these foods. Here you can see there is a graph, and we had to we were surprised that the toaster strudel was less than the chocolate milk, and it wasn't the same or higher as the chocolate milk.
So I tested different combinations of fat and lyes and made different soaps and tested the results.
We did color flames.
How did you do that? Well, we just bought colored flame candles off of Amazon and just lit them up. And then the candles were in a color to where every time we lit them up, that would be the color of the flame, but the flames would change just a little bit.
I did the lemon power project, and I thought that if you add more lemons, the more volts that will be produced. And me and my partner, who couldn't make it, we made this circuit thing, and we tested it with a multimeter.
I did my project on a phenomenon called the Stroop effect. And what it does is you have to read out a list of words in black ink and non-corresponding color ink. And how it works is your time on the non-corresponding color ink will become slower, because whenever you see the word, you have to make a decision if you want to perform the new task that you're not used to, or if you want to go what you're familiar with, which is reading, because for most humans, reading is an automatic skill.
My project was which hand sanitizer should you trust this flu season. I compared Germ-X, Purell, and antibacterial hand wipes, and I ended up comparing them to see that the hand wipes worked the best. The other ones, they grew a lot of colonies of bacteria, while the hand wipes actually didn't grow any. And it was over like a span of 2.5 weeks, so it was positive.
My project was eggshell geodes, which is where you take half of an eggshell and you submerge it into a solution of borax powder and boiling water, and you let it sit over for 1 to 2 nights, and it grows crystals like a regular geode.